Hello guys, welcome you to the TechWiz channel where we studying the statistics, which is the basic building block of any machine learning studies. So this is the fourth video of this series, and today we are going to start the very basic formulas of the statistics. And these formulas are called as the central tendency. We'll be studying in detail, and we'll be also studying that what are the functions we comes under the central tendency and which one should be used at what particular time. So I'll be meeting you at the whiteboard after our intro. So welcome you to the our whiteboard of the TechWiz lab, and we are going to start the study of the central tendency. So central tendency. Okay. So this word may be new for many of you guys, but don't hesitate about it. What we are going to study today, most of you would have been studying in the sixth or the seventh standards. The only point is like we just learned it then, and now we will see that how we can apply these things. So central tendency, just to remember this part, you can remember it like 3M. It's mean, median, and mode. Okay. So now suppose if I have a sample data set and I'll just write it like 4, 4, 5, and 6. Okay. Now suppose if we are going to calculate the mean of this data set, the median of this data set, and mode of this data set, then how we should calculate? Now what we mean by the mean, median, and the mode? So mean gives you an idea about the average. It's just a simple average of the data set, whatever you have. Whereas median gives you the middlemost data set, and mode gives you the frequent number of your data set. Okay, so now we'll take an example. Now when we say the simple average, it's being denoted by mu, and remember this mu because we are going to use it in various formulas in the future also. So it means like we'll be summing it up. So if we sum it, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Then this is 19 and 6 is comes to 25. So 25 divided by 1, 2, 3, 4, 5, 6, 7. So 25 divided by 7 will be as your average. Similarly, when we say the middle of the data set, so first we do the sorting. Now this number is already sorted and we take the middle data set. So now when we have the 7 data points, so the fourth will be the middle set. So that's how the fourth becomes the median. Okay. Now when we say that the frequent number which is coming into the data set, so here which number is coming more than one, so this is the number who has come more than one. So or anyone which is the highest. Okay. So this becomes your mode. So mode is 4. Now there are chances that none of the number has come frequently, like everybody has come for maybe once or twice or maybe thrice. So none of the data is coming onto the more frequent than any other of the data in your data set. In that case, the mode will be none because either you call it none or either you call every data set is your mode. So that doesn't make any sense in the statistics. So that's how we can call it none. And that none even will give you an information that the data set which you have taken, it has like none of the feature is actually holding some more important. So I'm pretty sure that you would be knowing these formulas from your sixth and the seventh standards, but now we'll try and understand what is their meaning in the real life and how we actually use them in our statistics studies. So we'll just go to the use of CT. Now, suppose we have the huge amount of data set which we are dealing with, and maybe like what is it? Okay, and we are not into the plotting the trend and doing something, or maybe we are making some rules in a mathematical modeling part, or maybe developing some features based on this, which we are going to put as an input to one of our machine learning model. So what happens is we directly select any one of them which was suitable when we were doing the training and the testing part. But when it goes to the reality or some new kind of data comes, sometimes these things create some issues, and then you see the drifts in the data, and again you need to be trained by applying those uh, data cleansing parts. So now you can understand that these very basic small blocks, what we are studying, the mean, median, mode, they can actually have a very much impact on your models as well as your mathematical models. So suppose if a data set is having mean is equals to median is equals to mode, it means it is normally distributed. Now, how normally distributed is like it's a kind of a Gaussian, okay, where this is a new like mean, median, and mode. Now, suppose if let's take some example, okay. So we took like we make a model, okay, which pass the average age of cities, or maybe let's take a small sample, that's like societies, visitors, okay. So we want to see that what kind of age people are mostly coming to my society as a visitor. So when we tried and developing this model, we thought that okay, the average will work actually. So we didn't study about it, and when we were taking the data was actually into the normal distribution. It means the 21 was the mean. Similarly, it was the median, and it was the mode. Okay. So now suppose what happens when there was one security guard who was doing something and he made a mistake in one of the age column out of 12. He just wrote, instead of 37, he wrote 137. Now you have a fully automated system. This number was read through the OCR, and that has been pushed to a queue, and now you are calculating the mean. Okay. Now when you will calculate the mean with one of the higher delta, your mean will increase drastically. Okay. So suppose if I take an example for 21, so there were 20 plus 21 plus 22 divided by 3, and it will come to the 21 as an average. Now suppose if I add 137 to this, then the 20 plus 21 plus 22 plus 137 divided by 4. Okay, so now you understand that how this one number can really change your this mu 2, and suppose this was my mu 1, then mu 2 is going to be very very high than your mu 1. Now that wrongly inputted data will definitely lead to your wrong prediction. And even if you have a mathematical model where you are using an average value, definitely your final answer is going to be spoiled just because of a system's mistake, or a kind of a mistake which lead you to the wrong inference of the data. Now, if suppose a human was sitting there and he saw the 137A, definitely will say that no, man, we need to discard this data. Yeah, it's not none, it's not missing, but definitely it seems to be a garbage data which we should exclude from our study. So we call it like the outlier data. So suppose if you will take the mean, mode, and median. Now previously this was the data. The mean was 21. The median is the middle one data that comes 21, and mode was like none of the mode. Okay. Now coming to this part, when you will see your mean will be coming to very very little than the 21. Okay. Whereas your median will still be shifted by 21.5 on, and mode is still none. Now if you see, if I would be having one check where I was checking that is my mean is nearby my median, and with the mode if the data is available with some percentage of error, which I can definitely allow to be an outlier, you will see that that rule would have been broken here. And this definitely indicate that as the mu has been increased drastically, it means some higher number has been added as an outlier. Similarly, suppose if somebody would have added the minus 37 age, then your mean would have been drastically reduced. So the only point is like you can be having the outlier in any of the site, and that outlier can change your mean, and that mean can lead you to the wrong results. That's why the mean, median, and mode, all these three things are necessary because they all three things are telling you a different story about your data. Mean is just giving you a simple average. Median is telling you that if I put them in a sorted order, what is the middle number? And mode is telling you that which number is coming frequently, means which number is having the higher weightage in your given data set. So that's how these all three things should be used. And while making any of the statistical inference or like making your some statements, or if you want to pass it to some mathematical model or even to the machine learning model, when you are preparing your data set, you should definitely consider these all 3 points and all these possibilities. And then you should develop your rules so that your data cleansing can be done at a good level, and you can always take care of coming of the outlier parts. So that's it. Uh, that's how like we can infer this information, and definitely we can bring out some useful uh, decisions or maybe some informations about the data at this stage right now. So that's it for the today's video. If you like this video, please like, share, and subscribe our channel, and also share with your friends. Tomorrow we are going to study more about the distributions, where we'll be taking the different type of distribution, and we'll be also discussing about the skewness, which is the graphical representation from the outlier data set, and also the kurtosis. So keep studying, keep connected, and keep watching our videos. Thank you so much.